So, hello, good morning, good evening, good afternoon, and everyone. Welcome to Quantum 101. Um, I would just like to read the code of conduct during the session so that we all adhere to it and we have a pleasant session. Thank you. So, just some basics. Um, all defamatory, abusive, profane, threatening, offensive, or illegal material is strictly prohibited. Discriminatory, hostile, or intimidating messages or language will not be tolerated, whether based on person's race, ethnicity, culture, national origin, social economic class, educational level, sex, sexual orientation, gender identity, etc. Internet society thrives to create and maintain a community in which people of many different backgrounds and cultures are treated with respect. Be mindful and respectful of linguistic background. While language for online discussion is mostly English, remember not everybody's language is English. Uh, Include only relevant portions of original messages in reply. Keep subject line concise and clear so that members can respond appropriately and easily search for archives. Avoid administrative messages such as remove me from the list. If relevant, add long message to the subject line. Do not spam several lists or libraries with the same message. Don't publicly post commercial messages. Use caution while discussing products. Information posted on the list and in libraries are please also carefully read the terms and conditions and have a great session. Thank you. Over to you, Valentine.
All right, then I think we are good to start. So, good evening, good morning, and good afternoon to everyone joining us from the different part of the world. I am Valentine Melkudi, and on the behalf of the Internet Society India Mumbai chapter, I very warmly welcome you all and thank you all for joining us for Quantum 101 today. This event is all about exploring the fascinating world of quantum, starting with the basics. We'll take a look at the fundamental principles that makes quantum physics so unique, and then gradually we'll dive into the future possibilities, including quantum computing, quantum internet, and a lot of other cool stuff. Whether you are
Recording in progress.
Whether you are completely new to the topic or already a bit familiar with the session, this session is designed to better understand how quantum technologies are shaping the world and what lies ahead in the future. Although before we get started, I'll just lay down quick guidelines and rules so we all are on track. So FYI, this meeting, as you already know, is being recorded and being live streamed at multiple platforms. Please keep your microphone muted unless you are invited to speak. If you have any questions during the session, feel free to drop them in the chat. We'll address them during the Q&A or as appropriate. Also, we encourage you to keep your cameras on if possible, so we have more connected meeting environment. Lastly, if you face any technical difficulty, please let us know in the chat. We are here to help. With that, I won't take much of your time. I'll now hand it over to Mitalee Joshi, who will be introducing our speaker for the evening. Thank you again for being here. I hope you enjoyed the session. Over to you, Mitalee.
Okay, thank you, Valentine. And good evening, good afternoon, and good morning to all. I am Mitalee Joshi, and it is my honor to introduce today's speaker, an individual who is making science not only understandable, but very exciting for the learners across the country. Please join me in welcoming Rajan Chopra, a dedicated educator, science influencer, and the founder of Blackhole Academy. Rajan is known for his remarkable ability to explain some of the most complex topics in science, especially in quantum mechanics and quantum computing, through simple and relatable language. What sets him apart is his unique teaching style. He seamlessly connects theoretical concepts with real world examples, helping learners to see the and beauty of science in everyday life. Whether it's a quantum phenomena or a fundamental physics principle, Rajan brings it to life with clarity and creativity. Through his educational content on platforms like YouTube and Instagram, he has built a strong and engaged community of science learners. He connects what we learn in the books with how it applies in the real life. This helps both the students and the educators to feel more confident about exploring science. We are thrilled to have with us today. Please join me in giving a warm welcome to Rajan Chopra. Rajan, over to you.
Okay, thank you so much. I hope I am audible and everyone can listen me clearly. So today I'll be sharing some of the concepts with you regarding quantum technology that is going to come in next 2 years. So I have prepared a presentation also. Let me share, then we can surely start. And also, I'll be using a little bit of Hindi in between the language. So if anyone has any doubt or any words they are unable to understand, then they can surely ask. Just give me a second.
Yes.
Yes.
Oh, okay, that's good. So today I'll be explaining about these things that I have mentioned here. First of all, we have to learn a few concepts of quantum computing and quantum mechanics especially. So it will be superposition principle. Believe me, it's super amazing, and I'm very excited for this. So quantum entanglement, quantum interference, these are the three concepts. Based on these concepts, the whole quantum computing, that technology, quantum technology is built. And after that, I'll be sharing a few words about how it is going to affect our nation. So I'll be focusing on the future of India in this direction. So I'll be talking about National Quantum Mission, which was started in 2024, and how it is going to affect the industries and market opportunities, and what are the opportunities in the area you can also focus on. So let's start. First of all, the most interesting part, superposition principle. Let us say, I hope you have heard about the word bits. The main computer science, we can say the main concept behind computer technology or the whole technology depends on the one concept like you may have heard different parts of computing, but the main thing we will be talking about is classical bit. So it's either 0 or 1, or we can say it's like a switch. Either it is on or off. So you can also see it here also, classical bit. The whole computing is based on this. So by manipulating these classical bits, we perform different tasks like showing the picture on our screen, or even what we are seeing on screen is also just because of these manipulating these classical bits. So now switching a little bit to Hindi language so that other viewers can also understand. So ये classical bits का मतलब होता है कि fundamental level पे हमारे पास कुछ switches होते हैं. Zero का meaning होता है, the meaning of zero is off switch, and the meaning of 1 is on switch. So, but let us say I have two classical bits. So I can, with the help of two classical bits, I can represent four different states, or states in the sense I can represent four different conditions with those classical bits. या फिर हम कह सकते हैं कि अगर मेरे पास दो different switches हैं तो मैं उसे चार different tasks को perform कर सकता हूं या represent कर सकता हूं. अगर मेरे पास 8 classical bits हैं, 0 1 की स्टेट में रह सकते हैं, स्विच ऑन हो सकता है, ऑफ हो सकता है, तो उन 3 बिट्स का यूज करके आई कैन रिप्रेजेंट 8 डिफरेंट इंफॉर्मेशंस. So using 3 bits of information, classical bits I am talking about, we have 8 different states. But फिर क्वांटम कंप्यूटर में क्या अलग होता है? फर्स्ट ऑफ ऑल, क्वांटम बिट्स और क्यूबिट्स इन शॉर्ट वी से, इसमें जस्ट एक ही चीज का फर्क होता है, विच इज in classical bits we have 8 different possibilities with 3 bits. But the main difference is, हमें अगर 8 different states को explore करना है तो we have to go one by one. On the other hand, in quantum case, we can explore all the possibilities at once. That is the main thing, and that is the main power of quantum bits or qubits, what we say. So with only 3 quantum bits or qubits, we can represent 8 different possibilities at the same time. And this property is called superposition. So let us say ki, for example, you are sitting in the room. You can be at one place at one time. But on the other hand, in quantum world, an electron can be in different places at the very same time, unless until you measure it. सो मेजर करने पे कुछ अजीब हो जाता है, या फिर वी कैन से इट collapse into a single state. And that collapsing is very important here. For example, if you toss a coin and in the air, can you say it is head or tail? No. You can only say it is in the superposition of head and tail. Mathematically, it can be represented by this equation. It's psi, alpha, 0, 1. It's a very weird equation to look at, but let me simplify it for you. This alpha gives the probability of dropping or collapsing the particle in zero state. Zero we can say off state. Like classical bits में मैंने बताया था कि एक switch होता है, या वो on हो सकता है या off हो सकता है. So alpha gives the probability of collapsing at zero, या फिर on होने की switch हम probability बता सकते हैं, off होने की probability बता सकते हैं. तो in quantum worlds everything is given by probability. You can also see here quantum bit. I have represented it just like a coin in air. So in air we can't say is it is 1 or 0 unless until we make a measurement. जैसे हम measurement करते हैं वो एक state में आके गिर जाता है. You can also understand this one using this analogy. It's Schrodinger cat analogy. So let us say in a box I have a cat and I put some poison gas in the same box. So can we say the cat is dead or alive without opening the box? It is not possible. But when you open the box, when you make the measurement, when you observe it, then it collapses into a single state. It is either alive or dead. But unless until you open the box or you are looking from outside, it is both alive and dead. It is not the best analogy or best example to give, but it's very close to understand how a qubit works. Let us say I have an electron. Electron has a spin of plus half or minus half. At the for the time being, let us say if I point my thumb upwards, it's spin up, and if I point downward, it's spin down. Unless until you measure an electron, you can't say if either it's upward or downward. So the measurement is the thing that collapse the state, collapse the particle into a single state. So it's the superposition. So in summary, superposition is a particle can be in different positions or different states. From the state, I mean condition. Let us say we will be using a different word. In the place of state, I can say condition. Electron can be in different conditions at the same time, but जैसे ही मैं उसको measure करने वाला हूं, the time I measure it, it collapses into a single state. And that's the thing we can take the advantage of. Also, let me blow your mind now. 3 classical bits का use करके I can manipulate it and we can get 8 different states. Quantum bit may be 8 different states. The only difference is I can explore all the different states at the very same time. That is the part missing in classical bits. So 3 classical bits को use करके मैं 8 different states को explore कर सकता हूँ. Now let's go further. If I use 300 classical bits, I can store 10 raised to power 90 different states. I can explore 10 raised to power 90. This is the number we can't even imagine. This is the number larger than the all the atoms combined in the universe. These many states can be explored at the very same time using quantum computer. That is the power of quantum computing, and that will give the exponential power. Can you see the thing I am sharing? Only using 300 qubits, we can explore 10 raised to power 90 states at the very same time. This is the exponential speed up over these classical computers. So I have also written here, using n qubits, we can explore 2 raised to power n, which is an exponential number at the very same time. That is the main power. But the main thing is, I have to explore 10 raised to power 90 states at the very same time. But to do that, I have to do one more thing. I have to learn one more thing, which is quantum entanglement. सिर्फ quantum superposition से काम नहीं चलने वाला है. हाँ, there are 10 raised to power 90 states, but they can only be explored only if I can entangle those particles. So in short, let me tell you what an entanglement is. I have also written a short definition, but let me tell you in short what it is. Let us say I have two particles, and somehow I have managed to interact these two particles. Let us say I have collided those two particles. If I measure the state of one particle, let us say spin of one particle, and I see after collapsing, it gets the spin up. So automatically the second particle gets spin down. And I have no idea how it is working, but it works. And in 2022, the Nobel Prize has also been given for proving this quantum entanglement. If you are from India and listening me, you may have seen the movie Karan Arjun. उसमें होता है कि अगर एक को मारा जाए तो दूसरे को भी दर्द होता है. बिल्कुल वैसा ही हम एनालॉजी से समझ सकते हैं कि if I make a measurement on one particle, then the state of other particles get also affected, irrespective how far apart they are. And that's the mind-bending thing, at least for me. If you place one entangled particle here on Earth and the other particle in somewhere in Andromeda galaxy, and you make a measurement on one particle that is here, then the state of other particles gets also affected. And that's the main thing about quantum entanglement. And using this entanglement, you can explore 10 raised to power 90 states using only 300 qubits. And that is the most difficult part also. Let us say अगर मैं दो पार्टिकल को लूं, उसको entangle करना चाहता हूं, so these particles can also entangle with the external environment, and that is the main issue with quantum computing. कि हम environment के साथ भी उन्हें entangle नहीं होने देना चाह रहे. We all only want that 300 qubits interact with each other and they get entangled so that we can explore numerous amount of states at the same time. That is the main challenge today, and that is the reason why we don't have that most efficient quantum computer at the moment, because being in that quantum entanglement state is a very difficult task. But if we get only 300 qubits in quantum entanglement state that we can explore, we can exceed the power of any supercomputer out there. So I have written few points here also you can study, and based on these two properties only, superposition, which is a particle can be in different states, and if you take two particles and entangle them, then you can explore the states of two particles at the very same time. So one particle, two states, two particle, there are four states. You can explore them at the very same time or simultaneously using this powerful property. But if there are 10 raised to power 90, or let me say it, almost infinite states, then how we are going to get the desired result? It is a very difficult task. From 10 raised to power 90, let us say, there is only one right answer, and that's a very huge number. So then the property comes quantum interference. So quantum interference is, if you want to get the desired result, you have to learn something like quantum interference. So you may have seen this experiment, double slit experiment, जिसमें दो slits होती हैं and there are different waves coming out of those slits. या फिर पानी में भी हमने काफी बार देखा है कि अगर हम दो हाथ से पानी में मारना स्टार्ट करें, then different ripples create हो जाती हैं जो कि आपस में मिलती हैं. Few parts अगर हम यहाँ पे देख पाए तो light है, few dark हैं. ये इंटरफेरेंस की ही वजह से होता है. अगर हम कोई भी ऐसे एक वेव को देखें तो अगर वेव का क्रस्ट आपस में मिलता है, ट्रफ आपस में मिलता है और एक दूसरे को एम्पलीफाई कर देते हैं, then we say it's constructive interference. And if crust of one wave and trough of other wave meets, then we say it's a destructive interference, or we can say they destroy each other. बस हमें यही करना होता है कि 10 raised to power 90 states में कुछ ऐसा करना हो, कुछ ऐसा, let me use the word magic at the moment, कुछ ऐसा magic use करना होगा such that all the incorrect answers after exploring 10 raised to power 90 states gets cancelled out. Only one left, which is the correct answer. And that is the main power of these three algorithms I have written here. Grover's search algorithm. So why we know the name of these three people, Grover, Shor, or there are David Deutsch. We know the name of these people because they have unlayered the magic part. कि how we are going to get the right answer from almost infinite state. These are the three algorithms, and I have to use mathematics in order to show the actual magic behind these algorithms, or how they are used to perform different tasks. So I think it's not the right time to share the main crux, or we can say the main magic behind these. So let's go forward. And by the way, after learning these three concepts, you have almost 50% mastered the quantum computing, leaving the mathematical part. So we almost know how a quantum computer works. We just want to replace the classical bit part, which is the main key or precursor of classical computing. I have a laptop in front of me. It is working just because of the manipulation of those classical bits. I just want to replace the fundamental part, which is classical bits, with quantum bits. So quantum bits have three properties, as I have shown: classical quantum superposition, entanglement, and quantum interference. And after learning these properties, you may have seen that quantum computers are mainly used to explore different possibilities at the very same time. And I have shown here what are the uses of exploring different states or different possibilities. So in cryptography, it's a two-way sword, I would say. कि दो धारी तलवार बोल सकते हैं हम हिंदी में, कि we can break almost any encryption method using quantum computer. At the very same time, we can build something called quantum safe encryption. So that's why I said two-way sword. तो हम एक ऐसा quantum internet बना सकते हैं which can only be destroyed by another quantum computer only. So that's why it's very important for almost all the countries to build a quantum computer. So breaking RSA method, you may have seen that in banking system, they have very large key. Let us say I have to break 100-digit, I have to make the factorization of 100-digit long number. It's a very, very, very difficult task for even classical supercomputer. The most powerful classical computer existing at the moment will be unable to give us the factors of 100-digit long quantum 100-digit long number. But on the other hand, quantum computing or quantum computers will surely break that in seconds. So there are different applications in drug discovery, as we have seen that there are millions of different proteins existing. In 2024, if I'm not wrong, there have been a Nobel Prize given for that protein structure to AlphaFold, I think. So there are millions of different proteins that can be that exist. So if we have to find the cure of something, let us say I have to find the solution of how polythene can be made biodegradable. So I have to use one of those proteins, and there are millions of possibilities. So I have to, using classical computer, I have to explore one by one how can it be made biodegradable. But on the other hand, I can explore millions of possibilities at the very same time using quantum computer. Obviously, if we have that much efficient quantum computer at the moment. Let's move further. We have different applications in financial modeling, like risk analysis or algorithmic trading. Let us say I have to send a package in US, and I have to find the best route possible so that I can send that package in the fastest time or in the shortest time possible. So exploring the different paths at the very same time, there can be millions of stops in between the path we will be following. So that can be explored using quantum computer at the very same time, as I have explained it to you in the previous slides also. So एक छोटी सी story भी share करना चाहूँगा. Last night I was generating an image using Sora. You may have heard about it. It's a image generator of OpenAI. So जैसे ही मैं उसको एक command देता था, एक prompt लिखता था, it takes a lot of time. Let's say something 1.5 minutes. So I asked my friend that, do you know why it takes so much time to generate even a single image? So he said, पैसे नहीं दिए होंगे तूने. So I said, no, I have paid plan, but still it takes a lot of time, because it does a lot of calculations behind the scene. So I just have to give a prompt, and behind the scene, it takes a lot of computational power to generate even a single image. If you are asking ChatGPT or Gemini or any chatbot that you want any kind of help, it takes a lot of computational power in order to give you the final answer. So that problem, or making a new large language model, is very difficult for let us say entrepreneurs. So if I have a very small amount to spend, and still I have to build let us say chat gpt like model, so I have to do one thing, that I have to spend a lot of money in order to do that, because it requires a lot of computational power, lots of super computers combined together in order to make that much big chatbots. So that problem can easily be solved, and even if I spend millions or billions of dollars in order to train a large language model, still it takes years to do that. So that problem can be solved using quantum computer. So it can combining artificial intelligence with quantum computer or machine learning algorithms. Combined, we use the word quantum machine learning algorithms. We can speed up it exponentially. So the exponential speed is a very big thing according to me. Let's go further. So let's jump here. National Quantum Mission, that so अब मैं मेरे ख्याल से हिंदी यूज कर सकता हूँ, because we are on नेशनल क्वांटम मिशन, जिसमें 2023 में इंडिया ने एक ऐसा टारगेट सेट किया है. वी हैव सेट अ टारगेट दैट बिटवीन दीज इयर्स 2023 to 2031 we will be becoming quantum nation. So very big task for us also. So it was 6,000 crore funding that was given by government to spread it, to give to different startups related to these quantum technology. It's not only about quantum computing, but different quantum technology that will be emerging, like quantum internet, quantum cryptography, quantum machine learning. Different startups, if they are working on something like quantum technology, then they will be receiving small portion of this amount. So different areas we are working on, it's quantum satellites and quantum internet. So we are expecting that by 2031 we will be having multiple cities where quantum internet will be used. That is the most secure internet for the future. So at the moment we are working on a quantum computer at TIFR, which has built the quantum computer carrying around 30 qubits, which is a very big task and very interesting to look at. Also, there are different possibilities and different companies and universities working on different areas, like quantum computing. IISc Bangalore and IISc Madras is working superconducting quantum computing. They are filing the different patents also. Photonic systems, ion trap platform, and on the other hand, IIT Madras along with CDOTS working on quantum cryptography, secure networks and satellite links. And there are different areas also you can also see here. Also, some companies are also very much coming in spotlight, like TCS along with IBM and HCL. They are also coming in this area and investing a large amount to build our quantum nation. So let's move forward. Yeah, here also I have mentioned that many companies are coming forward to give some contribution towards this area of research. And here I have listed different amount that different companies are giving to new startups. So by 2031, we are expecting that we will be becoming quantum nation, and we will be having a minimum of 3 to 4 quantum computers efficient enough to run the different algorithm that I have mentioned, like Shor's algorithm, in order to build the securest, or I would say the most powerful encryption system, so that we can be safe from different nations. That is the main concern at the moment. So the first country who will achieve quantum internet will be the most powerful country at the according to me. This line is given by me. It's my contribution. According to me, if we have built the most efficient quantum computer, we will be the leader in this, and we are on the urge of that, and we will surely do that. I think I have spoken enough, and if you have any question related to this, you can surely ask, so that it can be a two-way conversation and I don't have to speak that much. Thank you so much.
Okay, Rajan, there is a question in the chat. Can you see that? And sorry, I have a power
I
cut.
can ask him. So there's a question in the chat which says, I want to ask if Heisenberg's uncertainty principle, uncertainty principle comes under superposition.
No, these are two very different things. Heisenberg's uncertainty principle says if you measure the one property of a system, let us say I measure the position of a particle, then it's next to impossible to measure the momentum of the same particle with 100% accuracy. We call it quantum fuzziness, or quantum fuzziness is the best word I can remember at the moment. At the fundamental level, there are many fluctuations that are going on that we can't measure the exact thing at the same time, like two properties, energy and time. We cannot say at this time there is this much fixed amount of energy present in a quantum system. It's impossible to say according to uncertainty principle. That's why the word uncertainty is there. At the fundamental level, there are different uncertainties, or we say cannot be measured two simultaneous properties, like what I've said, position and momentum.
Oh, thank you. There is another one, I think. Can you share the highlights on quantum teleportation and significance in communication and quantum key distribution based on zero knowledge proofs?
Okay. So quantum teleportation, first of all, it's not like if I just अभी मैं यहाँ से गायब हो जाऊंगा और कहीं पे present हो जाऊंगा. It's not possible to do that, to disappear from one place and present on the other place. But at the same time, I would say disappearing or making invisible the information of one quantum system from here and appearing at the different place is possible. So transferring or teleporting the information or state of a quantum system is possible using quantum entanglement property. But teleportation of complete electron is not possible. That is the main misconception. If we have seen that in Star Trek, that people disappear from one side and appear on different spaceship, that is not possible. Quantum mechanics or quantum computing does not say it's possible, but it says that you can transfer the information or state of the particles. Okay.
All right, so there's a follow-up suggestion on this
How
one.
do you different? Yeah, let me read it. So
Yeah.
how do different interpretation of quantum mechanics influence our understanding? Okay, let me just give you a brief idea of this. As I opened my conversation, like an electron can be in different states at the very same time unless until you measure it, and the moment you measure it, it collapses into a single state. An electron has up spin or down spin, we cannot say unless until we measure it. So what happens at the moment of collapsing? That is the biggest mystery in quantum mechanics, and we call it quantum measurement problem. And it's an open problem that no one has the perfect answer. But we have different theories, like we say many world interpretation. if I do the experiment here in this universe and I get the spin of an electron upwards, it will be downward, but in some other universe. Believing it is a very difficult thing even for me, but there are many people like David Deutsch who was one of the what we say founding father of quantum computing, who believes in many world interpretation. Like if we make a measurement, like if I take a decision from two things, buying an ice cream or not buying an ice cream. So if I buy an ice cream in this universe, there will be some other Rajan in some other universe who will not buy it. So the reality splits into two parts. It's this, according to this many world interpretation of quantum mechanics. Even the reality splits into two parts, just like a river. अभी तक हम सोचते थे, we think like if I make a measurement, what happens at the time of collapsing of state? We had no idea, but this many world interpretation tries to give the answer that both the state occur, one in this universe and one in other universe. And also, if you are measuring the position of a particle, let us say I have an electron in my room, it can be in infinite different places at the same time, unless until I measure it. But when I measure it, it collapses into a single state or single position. But it also occurs or appears in different places also, but in some other universes. Believing it is a little difficult, as I say, but yeah, it's this information, interpretation. So there are different possibilities or different interpretations that different scientists give, but we don't have a perfect interpretation of quantum mechanics that is 100% true. We have different limitations of different interpretations. Few involve gravity, like one of the interpretation given by Roger Penrose. He said in collapsing state there is a small role of gravity also, but it's still an interpretation. We don't have the perfect answer for that. Unlike that general theory of relativity. General theory of relativity don't have different interpretation. It has a single interpretation, and it works almost all the time. Quantum mechanics is, if we go practically, or if we forget this part of interpretation, then it is more accurate as compared to general theory of relativity. Still, there are few missing puzzles that we at the moment don't understand. Okay.
Oh. So Abhinav writes, but I read somewhere that the principle says that we can't measure a position and momentum of a electron, or a particle at the same time. So I think it comes under superposition. And
So
it says
superposition, superposition was, we are talking about a single thing at the moment in superposition. Like I am talking about being in two different states at the same time. I am not saying that I am talking about position and momentum. No, those are completely different things. Those are called conjugate variables. Two variables comes together, like position, momentum, as I said, and energy, time, wave and particle nature of a particle. These are conjugate variables, and those fall under the roof of uncertainty principle. And under uncertainty principle talks about those variables. Like if you measure the time accurately of a quantum system, you can't say how much energy it carries. And if you know the exact amount of energy, you can't say for how much time it was holding that energy.
Okay, thank you.
Yes.
So it's Sapna says, I'm a BSc student now. I want to do MSc after this in physics. Can I pursue quantum computing as a career?
Okay. So this National Quantum Mission is planning that in 2025 or 26, they will be launching quantum computation course in 100 plus universities. So you can surely join that course. And believe me, I've written a line also. Just like, give me a second. It was, I think, कहीं हो गई होगी, but let me say it. अगर हम आज इस टेक्नोलॉजी को सीखते हैं, if we learn this technology today, we are preparing for future, and that future is not too far, it's just 2 years away. तो सिर्फ अगर आज सीख लेते हैं इस टेक्नोलॉजी को, तो क्वांटम कंप्यूटर्स हमने ऑलमोस्ट बना लिए हैं, एंड वी रिक्वायर अप्रोक्सीमेटली 10,000 या मैंने लिखा था यहाँ पे, बट ठीक है. I collected some of the data also so that you can see the actual number. Yeah, यहाँ पे लिखा है. So here you can see also 50,000 plus, according to few reports I have managed to see कि 50,000 plus new job opportunities हमें देखने को मिलने वाली हैं in this quantum area. So you can surely join that course that different universities will be launching, most probably in 2026.
Okay, thank you. Aniket says, in your opinion, how viable is quantum key distribution as a scalable solution for national or enterprise level security?
Okay, as I said, using quantum teleportation and quantum entanglement, we can build a quantum internet, or we can build quantum security or cryptographic system that cannot be broken by classical computers. No matter how many supercomputers or classical computers you combine. But using these tools or cryptographic methods, you can build these cryptographic system or quantum internet that can protect us from different nations. So if they are trying to break an encryption system, like it's the news of I think 2-3 months ago, China released a paper saying that one of their quantum computer has broken the military grade encryption system. They were able to break that one. But I read the paper, I converted it from Chinese to English, and that I read the paper, there was very flaws in that statement, and but it was not true. But if even the 5% of that thing is true, it's very, very, very horrible thing. So we have to work on quantum key distribution. It is a scalable thing. It takes time, but many companies are working, especially in India. Let me give you 1 or 2 names for that. There is a company called QEra. They are working on quantum key distribution, and they are finding the best solution so that we can scale it as much as we can. And you can also work on quantum machine learning. My area of research is also quantum machine learning. So you can surely work on that also. I can see that in the future, this will be the main thing, main key area of research.
Okay. Do you want to continue taking more questions, or do you want to continue with your presentation if there is
We can take
more
the
time?
questions, yeah. That is
Okay.
important, I think. Yeah.
All right, thank you. So somebody says, in photosynthesis, is there any quantum process?
We used to think that we completely understand photosynthesis process, but we haven't. It falls under quantum biology. So there are many quantum processes that at the moment we don't completely understand the very fundamental thing, why and how that photosynthesis work. But after exploring the quantum way or quantum path, we have seen that there are many different possible solutions. Using those solutions or quantum concepts, we can explore the different possibilities, how photosynthesis work and how life began on Earth. So in the starting, you may have Miller-Urey experiment. In that experiment, they shown that by mixing different chemicals or different gases, they were able to generate, or they were able to make an acid. I forgot the name, but that was very essential acid to start a life on Earth. So they just mixed the different chemicals and some spark also they used. So after mixing all those and keeping on table for few weeks, after that they knew that life was starting of life was quantum process. It was not classical process. It was at least we on Earth do not exist just because of someone has made us from outside. So it's completely quantum mechanical process.
Okay, let's going with the presentation. We have a dedicated Q&A in the end, so we can put more questions there.
I think I have covered almost everything from the presentation. I can surely share you that it's the complete data that I am presenting here. So we can go on towards the Q&A part.
Cool, then we'll take more questions.
Okay.
Okay, Navya says, what is the role of quantum in enrichment of artificial intelligence?
Artificial intelligence. Okay, I said, as I said, exploring different compute. The main use of quantum computing is to have the exponential speed up, and the computational power will be exponential. That is required for artificial intelligence. If you want to build a chat or a large language model, you have to wait for 2-3 years in order that it will learn all the data that is present on internet. But using quantum computer, that can be done in few days or few hours, depending on how much efficient quantum computers we have, because it does the work parallelly. So we can explore different possibilities at the very same time, and that can be very helpful for this building new large language models or even achieving AGIs.
Okay, Paridhi wants to ask, why does the information paradox happen in the black hole?
I can surely answer that, but it will be completely out of the topic. If you want, I can surely answer that, but it will take a few minutes, more than a few minutes.
That's okay, we have the time. That's fine, if you want.
Okay, I have no issue. So quantum, first of all, information paradox. Let me simplify it for you and give you an analogy. Let us say I have an apple in my hand. I drop it, I break it into atoms. Can we use those atoms and reverse the process? I can break the apple into atoms, but can I use those atoms in order to make an apple again? That was the main feel or main thing about information paradox. Whatever falls into the black hole, can we recover that information from the black hole? It was the main theme of that paradox. According to me, whatever falls into the black hole, it comes out of the black hole through that Hawking radiation, and that was the most of the physicists agree on this thing, that whatever falls inside the black hole, it becomes, or it merge into that Hawking radiations and comes out of the black hole, and then spread in the universe. But making that apple again is not possible. Or if I go on quantum level, I cannot make the exact copy of a quantum state. Similarly, if I want to, if I have all the atoms of that apple, I cannot place all the atoms at the same place according to uncertainty principle I have just discussed, on exact same place to build that apple. So that was the main theme behind this information paradox, कि इंफॉर्मेशन लॉस्ट होती है या फिर इंफॉर्मेशन को रिकवर किया जा सकता है. सो द आंसर जिस पे सभी ऑलमोस्ट मैक्सिमम नंबर ऑफ फिजिसिस्ट एग्री करते हैं, दैट वाज कि इंफॉर्मेशन को रिकवर किया जा सकता है, वरना जितनी भी फिजिक्स है, अदरवाइज होल फिजिक्स विल कोलैप्स. I hope I was able to give the answer.
Oh, yes, thank you. So Sarvajit says India is still at a nascent stage when it comes to quantum computing. We're expecting the first industry scale quantum hub park in January 2026. But by that time, we get a hang of technology that is outdated. My question is the in is that given the infra and budget limitations, what could be the way forward for India to keep up the global pace?
I think the main thing that we must focus on in educating the youth. Even if students are in 11th, 12th, we have to make them educated and about this technology. It's not that difficult subject to learn. Even I myself was teaching a few days ago. I was teaching for fun. I was teaching my students about this quantum technology or how these superposition entanglement works, and they were very excited about this. I could see the spark in their eyes that they are learning very new technology that will be used in coming future. And learning a future skill is a very interesting part. So the only thing or only limitation we have is spreading a word about quantum computing. That is lacking at the moment, nothing else. Everything can be done within that 6,000 crores. And we can be quantum nation or leader in this area. We just have to teach the right people just a step away.
Okay, are you ready for more questions or are you done?
So
There's a lot
I can
more.
answer, but I thought we have only 1 hour. So do you have separate
that's
questions also?
yeah, there are some questions that came up in the registration form.
Okay.
So yeah,
If
I
you can
mean,
highlight 1 or 2, I can surely answer those.
yeah.
I have already asked that in the chat box and you have answered those.
Oh, okay. So we'll take like two more questions and that will be it if that is okay with people.
Sure.
Okay, Abhinav asks, can quantum decoherence affect quantum computers?
So the main reason why quantum computers are not there at the moment is quantum decoherence. It's like as I said कि दो qubits को entangle करना होगा. We have to make two qubits entangled with each other, and by entanglement I mean I have to interact two qubits or two quantum particles. But they can interact with the environment also. That is called quantum decoherence. I have to uh, allow them to interact with each other only rather than interacting with environment. So that is the main limitation of today's quantum computer, and that is why we are shifting to those quantum technology which has minimum effect of interacting with environment. Like I am personally working on photonic. I'm studying at the moment about photonic quantum computers that uses photons as qubit. Photon can be in two states also. It has polarization of horizontal and vertical. It barely interacts with environment. Even it does not interact with itself also. So that is the main challenge for that also, to how to interact two photons together. But I think that is the future. Photonic quantum computer is the answer of this quantum decoherence part. If we use photons as qubit, then we can surely build those 300 or 1000 qubit quantum computer in by 2030, I think.
Okay, one of the last questions is, can you please explain how quantum dots work in TV or phone screens and how they make the pixels better?
Quantum dots is a very deep concept, and we are also working on uh, how these electrons or quantum dots can be used in order to make quantum computers. So we have different technologies, by the way. Let me clear this. We can use photons, we can use superconductors, we can use photons, electrons, nucleus, and topological particles, and ions we can use. We can use neutral atoms. So there are different types of qubits or quantum bits that can be used in order to make a quantum computer. To replace that classical bit, our only goal is to replace that classical bit with a quantum bit so that we can explore millions or billions or trillions of possibilities at the same time, so that we can have the exponential power, almost infinite times power than our classical computer. So this is one of those quantum dots. And in order to explain how these TV and photo screen works in single line, it's a little difficult for me to tell. So it's a very
Okay.
technical area, yeah.
Thank you. And last
Uh,
question.
I have
Sorry.
one question actually.
Okay.
How the future quantum internet will affect the internet that we have, like cryptography, DNS, and will it become obsolete? Like quantum internet will replace the classical internet?
No, I think quantum computer will not replace even classical computers. It will not replace it. The only thing is quantum computers will be useful for specific tasks only. Like if we have very confidential information related to our military, for example, then we have to make sure that it is placed in the safest area. So there we have to use quantum internet in military places, for example. Government will need that quantum computer in order to make the information most safe, at least from hackers. And even from different countries, if other countries have also built a quantum computer, they can very easily break the most powerful encryption system at the moment, RSA method, that banking system use. So if we deposit our amount in banks, so they use RSA. As I mentioned also, we have 100-digit long number. We just have to find the factorization of that. Just that step. If you find the factorization of that 100-digit or 200-digit number, you can steal all the money from a bank. But that is the most difficult part. In order to break 100-digit long number into factors, it can take more than the age of the universe. On the other hand, it can be done by quantum computers in minutes. So quantum computers will replace classical computers for specific tasks only, in very specific tasks. Not all the classical computers will be replaced. And quantum internet or quantum cryptography will be the most safe or safest in the near future.
Got it.
Okay, and last question of Ahmed. In case of a conflict with the use of quantum computer, a country can break keys of credit cards of the people.
I don't think so. Quantum computer will be used for that, but countries will try different possibilities. Different countries. So we have to make a quantum computer quantum cryptography. That will be the safest one. We can only break quantum cryptography or quantum encryption using a quantum computer. So if you want to beat Undertaker, you have to find another candidate who is able to beat that WWE champion. So in front of quantum computer, you have to place a quantum computer in order to make it the safest. So in banking system or in government part or the areas where the securities should be or must be very high, there we will surely be using, or companies will surely be connecting with quantum computing companies. So the banking system, we will be surely using that quantum internet. And as I said, in military area, government websites. So those area where security must be very high, their classical computers will be replaced by quantum computers.
Okay, thank you. I don't see anything else in the chat. Unless anybody wants to unmute themselves and ask you a question. Yeah, I don't see anything happening. So, over to you, Mitalee. You're on mute.
Okay. Are we going to play the picture first, or I just wrap up?
You can wrap up. We'll take the pictures in the end.
Okay. Okay, now let's wrap up this session. Thank you everyone for your questions. I hope all of you got your doubts clear. Thank you so much, Rajan, for the insightful and engaging session. Your way of explaining complex concepts made everything feel so inspiring. We truly appreciate the clarity and passion you brought into the discussion. Hope you do much more work, great works ahead. And thank you once again. And a special thank you to Nupur, our chapter president, and Narola and Gungun for our chapter leaders for whose leadership and dedication made this event possible. We are also deeply grateful for our wonderful advisors, Nandita, Pratik, and Shweta, for their constant guidance and support. A very big shout out to Valentine for creative flyer design and for originally coming up for the idea of this event. Thank you, Sarojit, for compiling our event as our repertoire. A special thank you to Jolly for live streaming our event today's event. Jolly is always there to help us, even when we reach out at the last moment. We truly appreciate that. Thank you, Jolly. Behind the scene made the difference. And finally, a heartfelt thank you to our audience for taking their time to join us and making this event meaningful and successful. Thank you once again, Rajan, for your sharing your time and knowledge with us. Thank you all. Have a great time. Over to you, Valentine.
Thank you to Mitalee as well. She has done a lot of hard work in the background. So I request everyone to turn on their cameras so we can have a picture. Okay, smile. Done. We are done.
Thank you.